Hi everybody, my name is Mntwana, so let's get started. So we have a question here. They say 20 kilogram block raising on a rough horizontal surface. See, this surface is like a table here. So they say this is the rough. Is rough. What does that mean? If this is rough, means there's a friction force. We're gonna see now if we have or we're gonna calculate it. This is connected by the block P. Oh, so this 20 is connected all the way to block P, but a P is glued with a Q. Oh, so they're together? Oh yes. Then let's say there's a light inextensible string. Light inextensible string, you see this string here? It doesn't have no mass. Okay? Moving over frictionless pulley. See, there's a pulley here. Like pulley, the tie here and stuff is moving. Now, and then they say P and Q are glued together and have a combined mass. Oh, so this P and Q, they give us combined mass of M. So they say somebody's been pulling this with a 35 Newton. So you know what? I'm pulling this. Why are you pulling? So who knows? Let's wait. Maybe this stuff was falling. So he decided to say, hey, I'm gonna have to pull you back. Please don't fall. Okay. So now they say here a larger mass, a larger force of 35 is applied to the 20 kilograms. See, with a 40 horizontal shown below. Now they say 20 kilogram. Now the question. Now let's go to the question. Let's get to the question now. They say 20 kilogram block experience a friction force. Oh, so this block here is gonna start to feel like friction force. Okay, so what that mean? Look, people, when there's a friction force here, because there's a contact between the table and the surface in the table, means there's a contact there, so there's a friction force. Like, look, scratch your hand, you're gonna start to feel hot. Why? Because there's a friction force between your hand and hand. You see? Now let's get to the question now. So in the question now, you say, let's solve it. It's easy. So I'm gonna say here, look, they say here, so the block of 20 kilogram has been experiencing a friction force of 5 Newton as it moved to the right. Oh, so it seems like this stuff was accelerate to the right. That's why we have to pull it back. So let me tell you something here, okay? Now, so we had to pull it back with what today? 35 Newton. Okay, so before we go any further, let me show you something very, very important. Whenever you have a triangle, quick, all right, it's not part of it, but it's very important. You have a triangle like this. Let's say this is 5 Newton, 3 Newton, and here let's say theta. They say find adjacent. Adjacent is horizontal, so adjacent is always cos. Adjacent is cos. You've seen that, never forget. So I'm gonna say my adjacent is cos. So I'll say cos of my angle. You always multiply by hypotenuse. So multiply by 3. So adjacent is cos. Don't even say SOHCAHTOA or whatever. No, adjacent is cos. It's simple like that. What about opposite? Opposite sine. So I'm gonna come and say sine. What is my angle? Theta. But if it's 40, you write 40. If it's 60, you write whichever angle. So for now, it's theta, and they'll multiply by your adjacent 3. So we're gonna play the same game here. I'll say, okay, let me extend it. And then like triangle. So this is adjacent. What is adjacent? Adjacent is cos. So I'm gonna say, okay, so here is gonna be what? Cos 40, and then multiply by hypotenuse, which is 35 Newton. Oh, so that's gonna give us what? F of x. Like that force which are pulling, we had to resolve it because we're gonna be dealing with a horizontal force or only vertical force. You don't want to deal with the inclination or whatever. So that's why we have to resolve this force which goes that way, 35, and make it horizontal. Okay? Now, so for the vertical one, we know for vertical one, it's going to be what? It's going to be fx equal to, that means this one here, equal to 35 sine 40, because vertical is sine. So the space is not enough. So I can just say for this one, it's going to be sine 40, but before we must multiply by that 35. Now let's not solving this stuff we didn't ask us. Let's get back to the questions. Now let's say here, this stuff was moving. So the block 20 was experienced force. So look, this stuff is moving that way. So since there's a contact between the table or the surface and the block. That's why there's a friction force, which is what is 5 Newton. But the friction force always opposing the motion of the body or block. So this block go that way, that way. So the friction force is opposed. So we're gonna say this is how it accelerates. But we have our friction force here. Our friction force is here on the surface is opposing. So our friction force equal to 5 Newton. Oh yeah. You see? And then what do they want? So the first question, let's say explain normal force. So normal force is if you have a surface like this and then you have an object here. Are you with me? Okay. If you have a surface like that and then you have an object here. So now the force which is we're gonna have a force which acts vertical downward. This is a force of gravity, force of Fg, force of gravity, and this will represent using the mass of this object of a block, and then you multiply by gravitational force, which is 9.8, is constant. But from the surface here, you see the surface here, you're gonna have a force which comes from the surface toward the object. So from the surface toward the object, and that's what we call normal force. So normal force is kind of opposed force of gravity. So that's why we call it, this is a perpendicular force because it make angle 90. So by professional or dictionary definition or mathematical definition, it says normal force is the perpendicular force. Yes, it's a perpendicular force because make angle 90. Exerted by the surface. Oh yes, it comes from the surface. See? Normal force it comes from here and it opposes, and the force of gravity starts from the center of object toward. I said again, force of gravity is come from the center of object of a block downward, but the force of normal comes from the surface toward the object. That's why we say normal force is the perpendicular in the actual definition. Normal force is the perpendicular force exerted by the surface onto an object that is intact with the surface. You can just Google that. You can try to check in a book. That's the definition of normal force. Now, let's go back to the second one. What do they want? Normal force, we know. Oh, yeah, we know. We're confident and we're happy. Now, let's calculate the combined. Draw what a free body diagram of 20 kilograms. So for free body diagram, what you do, you just allocate those forces. It's very easy. So I'm gonna draw my 20 kilograms. So don't write 20 kilograms, just write big a solid dot and then allocate all those forces, not the resolved force, no. So we're gonna say here we have first force of gravity. Oh, I have not forgot. But if we have force of gravity, we must have a normal. But since it's there, so we're gonna say okay, force normal is gonna come in. And remember here we're gonna have a tension. You know why? Because this object is moving that way. So now, when you look at this is what we call force diagram. You see this one here? This is the force diagram. But what I'm showing you now is a free body diagram. But what I just show you here, this is a force diagram. So we're gonna say now, okay, we have force of gravity. So now we allocate now all the force which acting on this. Force of gravity, normal, force of normal. This tension here because on a string. So this, no, we don't have anything here. I'm wrong because, like I said, you do not represent a resolved force onto free body diagram. No, is unacceptable. So the only force here we have is this, that actual force, not the one that you have resolved, which is what 35 Newton. Now, a bottle of water, just a little. What is the question then? So this is a free body diagram. That's all. Okay. Now let's go to the next one. Now let's say what the combined mass M. Oh, okay. Combined mass M. So this is kind of the spontaneous equation of this type of mechanical and pulley. It's more of the spontaneous for the most cases. So let's say find the combined force. So what you do not take both. You're gonna get confused. Start with mass M, deal with it, and then wherever you're gonna stop, like here, for example, me, I'll say, okay, so this one here, where the stuff move is moving down, we know. They say that. So now means, well, how does it move down? Because we have a force of gravity here. And for that case means you have a tension. So for that case now, we can apply what? Newton's second law of motion. Newton's second law of motion. Say Newton's second law, you must write that. Newton in exam second law of motion. So how are we gonna get that? We say, okay, F net equal to mass means force net or resultant force equal to mass times acceleration. But what happened? Acceleration is going to be equal to 0. Who can try? Why? Because of the constant speed. Whenever you have a constant speed, steady velocity which does not change, meaning there is no acceleration. If you're going to drive from here all the way to Soweto or all the way to Alexandria or any African country or any European country or any country, meaning if your speed is the same or did not change, means you do not accelerate. Okay, so they say constant speed means acceleration equal to 0, so 0 times m equal to 0. What is F net? So if I come here, F net means take a bigger force minus smaller force. So this stuff was moving down means Fg was bigger. So Fg will represent by using mg because mass times gravity minus tension for vertical motion. Maybe I could have said here vertical motion because some of you will say, oh, do you know vertical motion? So I'm gonna say now, okay, I will say Fg minus 10 equal to 0 because say mass equal to 0, acceleration equal to 0. So what do you want? What is Fg? Fg equal to mass times acceleration. So I can say mass times acceleration, mass times acceleration. But a mass is like P and Q together, you know. So what I'm gonna do, my intention, I want to get what? M. M is the combination of P and Q. So I can simply take over. So mg equal to T divided by G divided by T. This and this cancel. So we can simply say here, oh my gosh, sorry. We can simply say our mass we're looking for equal to tension over gravity. So the problem is gravitational force we know, gravity, acceleration due to gravity equal to 9.8 is constant, is 9. But the problem, we don't have a tension. So for that case, you start there, call it, let's say, one equation. Now we want to go and solve another object. They didn't even ask us, but that's how it's going to help you to get this. So if you come to 20 kilograms, where this object moving, listen people, you need to know where object moving. That's very important. So you know if object moving that other direction means your force is bigger. For example, if we push a car 20 of us and the car is moving further, what does that mean? What that tells us, we have more force compared to the friction force or resultant force of the car or the one which is opposing. So this object moving to the right. So which one moving to the right? You look those forces is tension. So you can simply here say for 20 kilogram. 20 kilogram. From the Newton's second law of motion, don't forget it. We say what? Which force is bigger? Tension, because moving that way. And the only force exists here is tension. We minus any force which is opposing. What is that opposing? Friction force, because we had a 5 Newton. 5 Newton friction force. Which are the opposing? Oh, we have this force which is opposing. But we must take a horizontal motion. Which force is this? This force is 35 cos of 40, the horizontal one. Oh, so we're going to minus this force is opposing because there's no way we're going to minus 35 because 35 is not in the same line. So minus this force, which is 35 cos 40, because from Newton's second law, say F net equal to mass. See? So when you minus this equal to mass acceleration, because F net equal to mass. So we take our force, which is T, minus any force opposing, friction force, and this is 35 cos theta equal to mass. Mass times acceleration. But our acceleration equal to 0 because this stuff move with a constant velocity. So m times a means whatever you have times 0 equal to 0. So we want to get t. So how are we going to get t? Take all this stuff to the right. Hey, you and you, go to the right. Don't come here and waste your time and distract us. Go to the right. So when it goes over, we're going to say t equal to, if f is a positive, and then plus 35 cos of 40. So we know the value. Plug it in. Our tension equal to, what is friction force? 5 Newton plus 30. Where did I get 35 from? Yeah, 35. 35 cos of 40. So tension equal to, plug it in the calculator. When you plug in the calculator, it's going to be 35.81. 35.81. Oh, so we have a tension, which is the force of Newton. So when you get tension, we can take all this tension into here, please. And let's finish up. So our tension, because I don't need most of the stuff here now. Okay, so we're going to say our tension equal to 35.81 over gravitational 9.8, and this is going to give us 3.25. 3.25. But this is what, oh man, what am I doing now? It's a mass we're looking for. We're looking for mass equal tension over G. Our tension, we had it here just now over G 9.8. So what we have is mass, which we're going to measure in kilograms. So our mass equal to 3.25. Mass equal to 3.25 kilogram. Now we want to go for the last part. Now look now, that I'm going to trace here. Okay, now look. So let's say here, excuse me, drink of water now. Look, they say, how did I say here? They say now, for 2.4. Now, it's in a certain stage, means at a certain stage, we're going to watch a lot of things here, so all the stuff, we don't need them. Okay. Okay, cool. So this in a certain stage, a block Q break off and fall down. My God. So you tell me this stuff was moving. All of a sudden, this stuff, it falls away and break off. So it means you're going to be left with the what with a small mass compared to before. So what that tells you, if it, okay, no. I want to give you an example, simple example. If let's say we pull something, me, you, and my friends, let's pull 1, 2, 3. What happened? Means it's going to move quick. It means whatever we pull is going to accelerate quicker. Okay? But now, because now P and QM is like a pulling, is the one who pull object down. So if you would move some weight, if you remove some weight, what happens? Means this can be smaller. Mass M is going to be less. And if mass M is less, means even tension is going to be affected. So my question, is it going to be moving fast or is it going to be moving slow? No, the velocity is going to decrease, people. Because it's not going to accelerate like how it was before. Look, the weight here is going to be too small to pull this quicker like, no, it's going to be too small. See what I'm saying? It cannot handle it. So the velocity is going to decrease. Will decrease. How? Because look, from Newton's second law of motion, say if net equal to ma. Okay? So what is F net? Our F net means change in force. So now if this some of the mass being affected means by decreasing means even the net force or resultant force is gonna decrease. In other way, acceleration is gonna be what? Smaller. Okay? And if acceleration gets smaller, meaning even the velocity is gonna get smaller. So for that case, okay, velocity is gonna decrease. Okay, reason just like I say, because of the Newton's second law of motion. If net equal to ma, So now if the net force being affected, see, because this net force can be affected because our mg minus t is going to be two way less compared to before. So for that case now, the velocity is gonna decrease. So velocity is gonna decrease. Reason? Just like I provided. See? So look, some of you might be new here, right? So please just come here, show me some love, show me real love for sure. So we can continue this movement, man. You know, I enjoy doing this. I enjoy doing this. So I can, it makes me happy when I can like, hey, Mntwana, I learned something from you, from your stuff. So make sure you come here, subscribe, share it with a lot of people, and I'll see you very soon. Thank you for your time. I hope you learned for me. Thanks a lot. It's Mntwana here. Thank you. I'll see you.